Hello, my name is Danish and I am from Mapping Your Way. Mapping Your Way assisting you in visualizing your data and seeing the bigger picture of what you can do with it. Mapping Your Way utilizes geospatial and mapping solutions to visualize your numerical figures and see how they relate to each other. Today, we will be exploring on how we can map out ethnic distribution of a region at a micro level. Have you wondered how can you produce a map similar as shown on the screen here? This is an example map of ethnicity distribution of Penang in Malaysia. As you can see, at different parts of Penang reflects different ethnic composition. The question is, how did I manage to produce this map? Today, we will have a two-part video on how we can do this. In order for us to achieve this, you need to have two datasets. One is a spatial dataset, as you can see, of the polygons that make up the island and the mainland. Secondly, you do need to have the numerical data. Chances are in an Excel format which underpins the categorization of ethnicities. I specifically chose Malaysia today because it's a good example where it is quite difficult to obtain this sort of data sets freely. In the first part of the video, we will be examining on how we can clean up and prepare the Excel data ready for visualization in the GIS. This is a very good example of an Excel data showing the ethnic composition of the state of Selangor, Malaysia. Selangor happens to be the most populous state in Malaysia. As we do not have access to micro-level population data of Selangor, I have decided to obtain the polling district level ethnic records. In this Excel spreadsheet, you can see the percentage figures for the various ethnic groups. The Malay, the Chinese, the Indians, and all the other groupings. This is a good example of a prepared Excel data. However, not all the time your Excel data will look what you want. The most important aspect is to have a unique identifier for each of your polling districts. You may ask why. In order for a successful linkage of the Excel data and the spatial data, for example as shown here, there are two factors that you need to consider for your unique identifier. One, your unique identifier type format. The data format must be the same. In this case, in Excel it is in text. And let's look at the unique identifier for the spatial files. It is a string, hence it is a text. That's the first thing. Secondly, these values must be the same as the ones here. So before we embark the cleansing of data, it is important for us to know whether the existing Excel data here actually links up with the spatial data, because we want to save time and avoiding unnecessary mistakes. Since I'm going to utilize ArcGIS, I strongly recommend the Excel format of this dataset to be of the 1997 to 2003 version .xls. Refrain from using CSV or XLSX, which is the latest Excel version, as it may cause issues in changing the attribute values and affecting the joinage. I'll show you why. So let's add this data, and let's say we are going to choose the latest version of Excel. You get an error. So choose the older version of Excel. Choose the sheet. In this case, it is sheet 1. choose this, press add. Let's open the attribute tables of both of them. It is important to know that the number of records here, even though it claims there's 916 of them, that at the end of the day, when it joined, it should match up with the number of records in the spatial data. This is on the assumption that your spatial data is correct. In this case, it has 894 records. And here, we trust that there are 894 records for your Excel file. Let's do a join. The unique identifier here happens to be code. For the table, code_dm, validate the join. Success. This is a very ideal scenario where you have 894 records matched together. Should there are any records missing from the join, please go back immediately to your Excel file to rectify all of them. That is why we are doing the checks here.